So, welcome. Like, for example, I want to estimate my population parameter mu. That is population mean. So, for this, I want to estimate this. For this, I can have like several unbiased estimators. So maybe I can have my sample mean, maybe an unbiased estimator. I can have maybe a sample median, maybe unbiased estimator. Also, I can have maybe a sample mode, maybe an unbiased estimator. I'm denoting it as X bar. This can be, I'm calling as X crown, and this can be, I'm calling as X dot. So, for a given population parameter, you can have several unbiased estimators. Of course, they are also called as statistics, sample statistics. But of which, if you calculate the variance of X bar, maybe for infinite population, it seems to be, it is sigma square by n. So as n tends to infinity, variance of X bar is becoming 0. So what we can say, a population parameter can have many unbiased estimators, of which only one will have minimum variance. So that is known as an efficient estimator. So in this example, my population parameter is mu, the population mean. For this population mean, I can have several unbiased estimators, unbiased sample statistics. Maybe they are sample mean X bar, sample median, sample mode, and so on. So, of all these unbiased estimators, if you calculate variance of X bar, it is coming out to be sigma square by n. So as n tends to infinity, sigma square by n becoming 0, which means that the variance of sample mean is very small for large sample size. That's why X bar becomes an efficient, unbiased estimator of population mean. Still, now somebody has asked me, like, how do you check whether it is unbiased or not? Again, I'm coming to the same concept here. Suppose if your population parameter is population mean, is my parameter. Yes, but actually, we are not having those formulas in our syllabus. Still, we have the formula for variance of X bar, and it is becoming 0 as small n, that is sample size is large. We will call it as efficient unbiased. Yeah, your query is correct. Like suppose population mean is mu, this is my parameter. So somebody has asked me, how do you check unbiasedness? It's not a problem. So its estimator is a sample statistic. So one of the estimator I'm calling as sample mean. But just now we proved that the expectation of your random variable, your sample statistic, your sample mean is mu. This we have already proved, which means that what happened? X bar becomes an unbiased estimator of mu. Similarly, sample median also becomes unbiased estimator of mu. That's what. So any queries about this? Yeah, thanks for this. Yeah, now we will have some problems to be solved. Before going to that, I'll have a small discussion with which I can close the 7th unit. Then again, I'll come back to problems. Just only for a while, just only a 10 minutes time, I'll complete a few topics of this. So now, anyhow, there are some more other sampling methods than simple random sampling are available in the market. So there may be stratified random sampling, cluster sampling, systematic sampling, convenience sampling, and judgment sampling. Because 7th unit deals with the sampling and sampling distribution, so far we have only concentrated on simple random sampling to select samples. But other than this, you have stratified random sampling, cluster sampling, systematic sampling, convenience sampling, and judgment sampling. So what is a stratified random sampling? Of course, you know very well the population is subdivided into homogeneous groups called stratum. And from each homogeneous group, you will have a simple random sample. This is known as what? Stratified random sample. So I'll repeat that a stratified random sample means the whole population under study can be divided into homogeneous groups based on particular characteristics. From each homogeneous group calling as a stratum, we apply simple random sampling. This is what we have. You can have good examples for this, right? Suppose if you want to draw some climate data based on the geographical regions, the whole population of India can be divided into different stratums. From each stratum, we apply simple random sample and do the sampling method, right? Now, the next method is cluster sampling. So what do you mean by cluster sample? Based on a particular characteristic, you will divide the whole population into different groups called clusters. For example, if you want to draw any particular data from Indian population, maybe you will divide the whole population into cities. They are called clusters. Now, we will sample the clusters here. This point should be noted. Like suppose the whole population can be divided into 1,000 clusters. So from these 1,000 clusters, we will draw only few clusters from simple random sampling. So in stratified random sampling, you are applying simple random sampling to each stratum. Whereas in cluster sampling, you are applying the concept of simple random sampling to sample clusters than the elements in the clusters. So now, after sampling the clusters, the elements in the clusters becomes a good sample. Maybe this is one of the methods. So you can see that the advantage is that the close proximity of elements can be cost effective in this case. But the disadvantage is that this method generally requires a larger total sample size than simple or stratified random sample. Third one is systematic sample. It's very simple. Like suppose you have 10,000 items, you will take the first item randomly. From that item, systematically, maybe you can select the 100th item, or 10th item, or 150th item, like that. The question is that the first item can be selected randomly. After systematically, every 100th item, every 150th item, you can take as a sample item. So if a sample size of small n is desired from a population containing capital N elements, we might sample one element from every n by n elements in the population. We randomly select one of the first n by n elements from the population list. We then select every n by nth element that follows in the population list. So this method has the properties of a simple random sample, especially if the list of the population elements is a random ordering. That's true. For example, the sample 100th listing in a telephone book is, of course, it's a systematic sampling. So please remember, a systematic sampling is always usually will be easier to identify than it would be simple random sampling per use. Please remember, I want to say one thing. Suppose there are like 1 lakh items. Then you have to fix whether you have to take every 50th item or every 100th item or every 200th item. After that, from the first 100, you will choose a item randomly. From that item onwards, every 100th item, what we have fixed, that you will take. This is a systematic sampling. The next one is convenience sampling. It is the name itself says that based on our convenience only, we are applying the sampling. So it is a non-probability sampling technique. Items included in the sample without known probabilities are being selected. The sample is identified primarily by convenience. Based on our convenience only, you will do these things. Advantage is sample selection and data collection are relatively easy because we are doing based on our convenience. But it may represent or it may not represent the whole population. For example, a professor conducting research might use student volunteers to constitute a sample rather than the people outside the institute. Actually, there is a small typo in the heading. This is the judgment sampling. Instead of convenience sampling, take it as judgment sampling. So it depends upon one's expertise or one's judgment. This whole process rely on. So the person most knowledgeable on the subject of the study selects elements of the population that he or she feels are most representative of the population. It depends upon the expertise. Of course, it is also a non-probability sampling technique. For example, a reporter might sample 3 or 4 senators, judging them as reflecting the general opinion of the Senate, like experts only. Advantage, it is relatively easy way of selecting because based on our expertise, we will select and for them we will collect the units. Disadvantage, of course, it depends upon the personal judgment. It may not completely reflect the population. But I want to tell you a simple thing like it is recommended that probability sampling methods. What are the probability sampling methods? Simple random sampling, stratified random sampling, cluster sampling, or systematic sampling be used because they are probabilistic. For these methods, formulas are available for evaluating the goodness of the sample, whether the sample is ideal or not, if it represents the population or not. An evaluation of the goodness cannot be made with non-probability sampling methods. So what generally we recommend is better to use probabilistic techniques to sample instead of non-probabilistic. Right? So I'll repeat what I have done in the last few slides. So in seventh unit, we are more interested in the process of drawing samples, right? So we have only studied simple random sampling in the earlier slides, But apart from simple random sampling, we have many other sampling techniques like stratified random sampling, cluster sampling, systematic sampling, convenience sampling, and judgment sampling, of which few are probabilistic sampling techniques and the other are non-probabilistic sampling techniques. So, stratified random sampling, cluster sampling, and systematic sampling are based on probabilistic sampling methods, whereas convenience sampling and judgment sampling are non-probability sampling methods. So just now I told you what is a simple random sampling, the basic thing. Now how do you do stratified random sampling? In stratified random sampling, the whole population can be divided into homogeneous groups called stratums, or simply strata. From each stratum, we use simple random sampling technique to collect the sample. So you will have many simple random samplings from stratums. The whole constitute a sample. What is the cluster sampling? Here the whole population is divided into clusters based on a particular characteristic. Now we use simple random sampling technique to sample clusters. Then the elements in the clusters which we sampled constitute sample. In systematic sample, we assume that all the units in the population are random and we fix every small n by capital N item to be sampled. So from the first small n by capital N items, we will pick one item randomly. From that item onwards, every small n by capital N item we will pick from the population. This is known as systematic sampling. So far, all these are probability sampling methods, whereas the other two are non-probability sampling methods known as convenience sampling or judgment sampling. Convenience sampling means it is based on the convenience of the person, we will collect sampling points or samples. Similarly, judgment sampling is the judgment sampling rely on the expertise of the person. So he will select the experts from the data from experts, and from that he will collect the data. But both these two samples doesn't represent the whole population actually, because convenience sample based on the convenience of the person, whereas judgment sampling based on the expertise of the person. So we recommend probabilistic sampling methods than the non-probabilistic, because for probabilistic sampling methods, we have formulas for evaluating the goodness of the sample results in terms of the closeness of the results to the population parameters being estimated. Yeah. So that's all from the unit 7. So we discussed how to collect a sample, what are the various methods for sampling, what is point estimation, what is the sampling distribution, what is the sampling distribution of X bar, and what is the sampling distribution of P bar, and what are the properties of point estimator. Now we'll solve some questions from this. So I'll take a small break and I'll come back with the problem set. So let us solve some problems from this unit. So the first question is chapter 7, problem 1. Consider a finite population with 5 elements labeled A, B, C, D, and E. 10 possible simple random samples of size 2 can be selected. List the 10 samples beginning with AB, AC, and so on. So can you please tell me what will be them? The 10 are AB, AC, AD, AE, BC, BD, B, CD, C, and D. Correct? Yeah. So using simple random sampling, what is the probability that each sample of size 2 is selected? So but I told you simple random sampling means each element has an equal chance of being included in the sample. So how many are there? There are 10. So each has a chance of being included in the sample is how much? Yeah, it's 0.1. Now, I have not added an interesting point in my slides. Yes, correct. It is random number table. So first of all, I'll add a point here, then I'll solve the question. So in simple random sampling, I told you that every unit has an equal chance of being included in the sample. So sometimes, how do you select a simple random sampling more practically? So for that, we have a concept called random number tables. So random number tables contains, of course, numbers. They are pure random in nature. With the help of those random numbers, we can easily select simple random samples. For example, I have 100 students. So what I'm doing is that I'll number the students from 0001 up to 90. So I have 100 two-digit numbers. I will go to a page called random number tables. From that random number tables, suppose if you want to take 10 students as a sample, I will collect 10 random numbers from the table. Those 10 random numbers corresponding students will constitute a sample. Yeah, I'll show that. Yeah, the question C says that assume random number 1. Yeah, see, assume random number 1 corresponds to A, random number 2 corresponds to B, and so on. List the simple random sample of size 2 that will be selected by using the random digit. So just now, so assume random number 1 corresponds to A, random number 2 corresponds to B, and so on. So 1 is for A, 2 is for B, 3 is for C, 4 is for D, and 5 is for E. Now I want to draw a sample of size 2, right? And I want to use these random numbers. So corresponding to 8, there will be no person. Corresponding to 0, there will be no person, right? Corresponding to 5, you have E. Corresponding to 7, we don't have any person. Again, corresponding to 5, you will have E. Corresponding to 3, you will have C. And corresponding to 2, you will have B. So we'll start with first 8. So 8, we don't have any person, so we discard. Next, we'll go to 0. We don't have any person, we'll discard. Next, we'll go to 5. We have a person, E. We'll have E. Next, we'll go to 7. We don't have any person, we'll discard. Next, we have 5. Because already you have included E in your sample, discard. Next, we have 3. Corresponding to 3, we have C. So the sample which we are taking is E and C. Any doubts? Yes. Any other queries? Yeah, I'll go to the next question. But meanwhile, I'll tell you one thing. What's that? Always remember that suppose there is a there is a class consisting of 100 students, right? So I want to select 5 students, right? Now, yeah, I'm not getting. Yeah. No, I'm not solving on the whiteboard because these problems are very simple. That's why I'm just pronouncing it. If you ask me to give it on whiteboard, I'll do that. Yeah. I'll repeat the question 1 minute. So here we are applying random numbers 1, 2, 3, 4, 5 to A, B, C, D, E. We want a sample of size 2 only. We have given these many numbers. So we'll start with 8. 8, no person. 0, no person. 5, yes, he is E. 7, no person. 5, yes, he is E, but E already selected. Next is 3. 3 means C. So we'll stop here because we need only a sample of size 2. So that's why our sample is E and C. Is it correct? Yes. Because that's why we are discarding 807. Correct. We we were given these numbers, but we don't want this because there are no people corresponding to 807, so we are discarding them. Yeah, thanks. I'll repeat. Actually, this is a question with a lot of confusion. I'll give a nice example to understand. Suppose there is a class having 100 students. I want to select 5 students. So what I am doing is that I am assigning numbers 00 to 99 because I am concentrating on 2 digits. 00 to 99 to all students. So total 100. So I want to select 5 students. So from the random number table data, I will select 5 numbers. Yes, I will select 5 numbers. Like for example, the first number is, the first 2-digit number is 32 I got. 32 means the person who is corresponding to 32 will be put it in the sample. Next number I got is 47. Then I'll take the student who is corresponding to 47 in the sample. Like that I will do. Understood? Yeah. I'll go to the next question. Assume a finite population has 350 elements. Just now I told you, because here 350 elements, it is a 3-digit. So what we will do? We will assign numbers from 000 to 349, like that. So assume a finite population has 350 elements. Using the last 3 digits of each of the following 5-digit random numbers, determine the first 4 elements that will be selected for the random sample. So he is asking us to take only the last 3 digits of the random number. Because he told me to take, we are taking. Otherwise, you have the independence of taking either the first 3 digits or the last 3 digits. It's up to you. But in the question, they asked us to take the last 3 digits, we are trying. So first number 601. There is no student corresponding to 601. So we will discard. Are you understanding? The next one is 022. Yeah, there is a student corresponding to 22. Next number is 448. Yes, no, there is no student corresponding. Yeah, correct. Next is 147. Include. 229. Include. 553. Discard. That's it. How many we need? We need the first 4. I think we have already included the 4. 0, 2, 2, 4, 4, 8, 1, 4, sorry, 0, 2, 2, 1, 4, 7, 2, 2, 9. 3 over. What is the next number? Yes, so we can include 147. So is it easy to understand? Any queries from this question? Yeah. Shall I move further? Yeah, I'll repeat. The question is that we have a finite population of 350 elements. Generally, what we will do, we will order them from 0000 to 349. Yeah, you are right. Because 2 times 147, so you have to discard. That's why we'll go to the next number, 289. Is it correct? Yes. So finally, what will be the sample? 601, discard. 22, include. 448, discard. 147, include. 229, include. 553, discard. Yeah, 147, discard. 289, include. That is the answer. No need to go for the last one. Thanks for the important suggestion. We'll go to the next question. Yeah. With replacement and without replacement, the nice question. You can do that. Yeah, if not specified, generally we'll go with a without replacement. That is more comfortable, right? Because once you have identified that, then why do you include it again? Because you want to make a, yeah, if you want to make a group of 4 people, why do you select the same person twice? Yes, it is 147 is with replacement. That the it depends upon the situation. That's what. Yeah, you can say that 147 can be included with replacement. But yes, yes, yes. Yeah. I'll go to the question number 12. A survey question for a sample of 150 individuals yielded 75 yes responses, 55 no responses, and 20 no opinions. What is the point estimate of the proportion in the population who respond yes? To calculate or to estimate a population proportion, what we do? We use a sample proportion. Now tell me, what is the sample proportion of yes? It is 75 by 150. 150. And what is sample proportion of no's? Yes, it is 55 by 150. Correct? Yes, correct. We'll go to the next question. A simple random sample of 5 months of, I'm just giving you the question number on the top of the slide. So if you want, you can remember it so that the question's answers are there with you. A simple random sample of 5 months of sales data provided the following information. Develop a point estimate of the population mean number of units sold per month. So you want to calculate the point estimate of population mean. Most of the time, point estimate of population mean is what? Sample mean. And also point estimate of population standard deviation is sample standard deviation. Correct? Yeah. So shall we try that? Yeah, we'll take a whiteboard and we'll try this question. Yeah, so we have the data. From that, if you calculate the X bar, so X bar is the point estimate of population. Sum of observations by number of observations. So sum of observations becomes 465 by number of observations is 5. That is 93. Now we want to calculate the point estimate for population standard deviation. The point estimate for population standard deviation is sample standard deviation. First of all, we'll calculate sample variance, then we'll go to sample standard deviation. Sample variance, please remember there is an interesting observation. Sample variance formula is S square is just sum all the deviations from sample mean, square it, add it and divide with n minus 1, not with n. This is the interesting point to remember. So what I am repeating is that the sample variance formula for a point estimate is not dividing with n. Yeah, good question. I think you might be knowing the probability statistics concepts, because if you put n, then sample variance cannot be an unbiased estimator of population variance. If you put n minus 1, then only sample variance becomes an unbiased estimator of population variance. But in such a case also, small s square becomes an unbiased estimator of sigma square. But S cannot be an unbiased estimator of S, but still we use that. So that's why we use n minus 1 so that small s square becomes an unbiased estimator of s square. I'll write here. Here what happens? Expectation of x bar is equal to mu. X bar is an unbiased estimator of mu. If you write this as a square, expectation of s square is sigma square. That is, s square is an unbiased estimator of sigma square. Yeah, though expectation of s is not equal to sigma. That is, s is not an unbiased estimator of sigma. But still, we use s square and s for population variance and population standard deviation. Understood? Any questions? Yeah, I'll do that. So we'll calculate this. So how do you do that? So we'll do like this. So we'll have, first we'll write the observation x bar, then we'll take the deviations from x, then we'll take the square of the deviations from x. So first observations are 94, 100, 85, 94 and 92. If you subtract from x bar, just now you calculated x bar is coming out to be 93. Please remember x bar is 93. You calculated it. So x minus x bar, 94 minus 93 is 1. This is 7. 85 minus 93 is minus 8. 94 minus 93 is 1. This is minus. You square it. This is 1. This is 49. This is 64. This is 1. And this is 1. So you total this. How much it is? 50 plus 64, 114. This is 116. So divide with, not with number of observations. Number of observations minus 1. So yeah, good. 4. This is your s square. So s square comes out to be how much? You'll get 2500 for 416. So it is 29. So s comes out to be square root of 29. I'm giving you the answer. I have that. It's 5.39. Understood? Any questions? Any questions? Shall I go further? Shall I go further? Shall I erase the board? Shall I erase the board? Yes. Thanks. Yeah. Sorry. Now, we'll go to the next question. The mean annual cost of automobile insurance is $939. It is question, problem number 26. Yeah, we'll go a little faster. What is the probability that a simple random sample of automobile insurance policies will have a sample mean within $25 of the population mean for each of the following sample sizes? What is the advantage of a larger sample size when attempting to estimate the population mean? Just go through the question. What we have? We have the mean annual cost of automobile insurance. That is, mu is there. Mu is $939 and sigma is $245. So what question I have asked? What is the probability that a simple random sample of automobile insurance policies will have a sample mean within $25 of the population? What do you mean by within $25 of population mean? Can I get any answer from your side? Yes, correct. So that's what we are doing here. So we are calculating the probability of a sample mean within $25 of the population mean. So let us try that. So I'm taking, yeah, correct. The sample size I'm taking 30, 50, 100 and 400. So let us try this question. So we have mu is 939 and we have we have sigma is, what is sigma? Sigma is equal to 245. Correct. So what is the sample size? I'm taking n equal to 30. Right? Now we know that, the sample mean, the point estimator of mu is sample mean is x bar follows normal distribution with mean mu and variance sigma square by n. Correct? That is, expectation of x bar variable is mu and variance of x bar is sigma square by n. Correct? So what is expectation of x bar is 939 and this is sigma square by n is 245. Then standard deviation of x bar is sigma by root n, that is 245 by root over 30. Correct? Yes or no? Then what I am asking you, correct. Right? So we'll go to the next one. So we want to calculate that the sample mean is within 25 of the population mean. So I'll go to the next page. So we want to calculate that a sample mean is within $25 of the population mean for each of the following samples. So let us calculate that. So shall we write the next page? Yeah. We want to calculate probability of the difference between population mean and population mean and the sample mean is within 25. Correct? Right? But we know that the sample statistic Z is X bar minus mu by, because it is within $25 of 939. Means it is $25 below 939, it is $25 above 939. Correct? So then, when X bar follows normal distribution with mean mu and variance sigma square by n, then what is the test statistic? Test statistic is X bar minus mu by sigma by root n. That is, X bar minus mean is 939 by sigma by root n is 245 by root 30. So we will convert this X bar minus 939 into Z. Yes or no? So what happens to the next one? So we will have probability of minus 25 by 245 by root 30 is less than or equal to, Z is less than or equal to 25 by 245 by root 30. That is, probability of minus 25 by 245 by root 30 is 0.56. So this is minus 0.56 less than or equal to Z, less than or equal to 0.56. Correct? So if we use normal tables, then you will get the probability. And you know very well how to use normal tables. Sure, I will share the solutions by next class, because if I show you the solutions immediately, it will be like a reading. Instead of that, let us try questions on the whiteboard, and whatever the problems we have done today, in the next lecture, I'll make it ready as a slide so that you can refer at any time. Is it okay for you? Is it okay for you? Yeah. Now, I'll ask you a small question here. I'll ask you a small question. Why suddenly this normal distribution came into the picture? Can you please tell me why? Can you please tell me why? Why we did so much of normal distribution here? Yes, very good. Because of central limit theorem. Yes, this is because of central limit theorem. Please remember that. Yeah, please remember that in this problem, you have mu is 939, sigma is 245. I have not told that the population is following normal. If population is following normal, obviously random variable X bar follows normal. But the population is not following normal. But the sample size is above 30, large. That's why by central limit theorem, obviously the corresponding estimator, the corresponding sample statistic, the corresponding sample mean X bar always follows normal distribution. With mean, how do you know with mean? Because expectation of X bar is mu, so with mean mu, and variance of X bar is sigma square by n, or standard deviation of X bar is sigma by root n. So that's why you wrote X bar follows normal distribution with mean mu and variance sigma square by n, or standard deviation sigma by n. Whenever X bar follows normal distribution, you will write the standard normal variable Z as X bar minus mean of X bar, that is mu, by standard deviation of X bar, that is sigma by root n. That's why Z equal to X bar minus mu by S sigma by root n. X bar minus mu is 939 by sigma is 245 by root 30. Got the answer? Any queries? So we'll do a few more questions on chapter 7 and we'll complete chapter 8 in the next lecture. Any questions? So shall we close down? That's all for today. Thanks.